Hey everybody, here is example A, and it says a 589-mile flight from Washington, D.C. to Chicago took 118 minutes. A flight of 1,452 miles from Washington, D.C. to Denver took 222 minutes. Model this relationship at time and distance time data. A flight from Washington, D.C. to Seattle takes 323 minutes. What is the distance traveled? If the distance between Washington, D.C. and Miami is 910 miles, how long will it take to fly from one of these two cities to the other? Okay, so there's two things we really need to know here. One of them is what are we trying to find and what do we know, right? So what's independent, what's dependent? So if you think about being a runner, runners often will measure their pace based on minutes per mile. So minutes per mile rather than miles per minute or miles per hour. So see how the time is the thing that kind of switches, and the distance also switches. So that's how we're kind of talking about inverses, all right? So if we know the time traveled and want to find the distance, then time is going to be our independent variable. So if we want to do that, say time is independent and distance is the dependent variable, all right? So then what we want to say is, let's look at what we have here. We know, excuse me, 589 is a distance and 118 is a time. So we can say 118, 589 could be 1 point that we know. And then we also have 222 minutes and 1452. So 222 minutes and 1452. All right. So there are 2 points that we have. So then what we can do is, can we find the slope? Sure. We can say 1452 minus 589 all over 222 minus 118. When we do that slope, you should get 863 over 104. All right. So we could say that is about 8.3 miles per minute. All right, so if we actually divide those out, you get about 8.3. Okay, so we can use our first point right here. We can write an equation to say our distance is going to equal 589 plus 863 over 104 times t minus 118. If you remember, this is just point slope form. Okay, so we would have our equation for distance. So if we want to try and find out the distance, we can just plug this in for time. Okay, so there we go. So then what we can do is let's find the distance between Washington, D.C. and Seattle. We want to substitute 323 in for time. So we're talking about D.C. to Seattle, 323. We're taking this number, plugging in for t. So you can say for D.C. to Seattle, we're going to say D equals 589 plus 863 over 104, parentheses. Instead of t, we are saying 323 minus 118. And when you do that whole thing, you should get it to be about 22,290.1, and we're going to say that is miles. So that's how many miles it would be about from D.C. to Seattle. All right, so then what we'd want to do is for the Miami one. Okay, so for Miami to Seattle, let's see here. So for Miami, what we're going to do is we're just going to go ahead and just erase all this, and we're going to start all over again. All right, let's see if we can get this to be a little bit bigger. So I'm going to erase it. Ready? Go. All right, so now what we're going to do is we know the distance, but we want to know the time. So now we can kind of say these two things have just been flip-flopped. Time is now dependent and distance is independent. So we're going to take these points and we're actually going to flip them around. So let's use a different color here. Let's use blue to now say we're going to have our new points would be 589, 118, and 1,452, 222. All right, so now we've just flip-flop our x's and our y's, which you know is the inverse anyway. Just switch the x and the y. So now if we can go through and we can solve this, well, we already know what the slope is, right? We can say the slope is just the opposite of what it was before, so it's going to be 104 over 863. Okay, so now we can write an equation to say time is going to equal, we can pick either one of our points to say that's going to be 118 plus 104 over 863, and we're going to put in parentheses our distance minus 589. Alright, so there is the equation here, and then all you'd have to do is plug this in and solve. So I'm going to leave that to you to check to see if you can get the correct answer for that to be about 157 minutes. Okay, so it should be about 157 minutes after you plug in the right distance for DC to Miami. So if you plug in 910 in here, you should get 157 minutes. Okay, there you go. Okay, so here is example B. It says, find the composition of this function with its inverse. Okay, so what we are going to do is, let's see if we can now write. It's not wanting me to do that. Maybe it wants me to do a different color. Okay, so maybe we have to move this guy over. Oh, I don't want that thing. What's going on here? Alright, so find the composition of the function with its inverse. So f of x equals 4 minus 3x. So what I want to do is I want to find its inverse. So find the inverse, which means we just have to switch the x and the y. So we can say x equals 4 minus 3y. 3y, and now we have to solve for y. Okay, so the first thing I'm going to subtract 4, so I get x minus 4 equals negative 3y, and divide by negative 3. So I end up with x minus 4 all divided by negative 3 equals y. So I want to do the function with its inverse. Alright, so we could just say, a better way to say this is that the inverse, f inverse of x, that's how we write the function inverse, equals x minus 4 over negative 3. Okay, so now we're going to say we want to find f of f inverse of x. So remember doing compositions. We need to take this thing and plug it in for the x in the original equation. So what I'm going to do is I would say this is the same as 4 minus 3, put parentheses in for the x of the original, and now I'm going to plug this thing in to there. Alright, so that means it's going to be x minus 4 over negative 3. Okay, so I can say distribute this negative 3 in, and I get 4 minus negative 3 times x is negative 3x, and negative 3 times negative 4 is positive 12, and I have to divide this all by negative 3 still. So that means the negative 3 and the negative 3 cancel out. This is just 4, and I left with 4 minus negative divided by negative is going to be a positive x, and then 4 divided by negative 3 is going to be negative 4. So I end up with this thing just equaling x. So when I take the composition of the function with its inverse, we're left with just x. That's it.